we also have to say a little bit about the types of storms, because it's different if we are talking about tropical storms, hurricanes, for instance, to mid-latitude thunderstorms. Now, one of the many factors which are affecting storms is the amount of heat present in the atmosphere. The warmer the atmosphere is, the more water vapor it can contain, and the more energy it has available to develop storms and to rain over the surface. So because we are warming up the atmosphere, we are actually giving more energy to feed storms. Now, when it comes to hurricanes, what we have seen in the last few years actually is a change in the patterns and in the locations where the tropical storms are forming, more than in the number of storms. And we have seen also some changes in the amount of time that it takes them to gain up energy and speed. When it comes instead to thunderstorms and mid-latitude storms, they have generally been increasing, especially in the quantity of water that is rained in a single time. So we're talking about extreme events. Maybe the overall amount of rain that falls over 1 year in a specific location did not change that much, but the way it rained changed. There are a lot of possible activities to work on mitigating or adapting to such conditions, from actually studying these extreme precipitation events and making better analysis and maybe better forecasts, because part of it is really understanding better how all of these systems form and interact. An important thing is actually to monitor and model the groundwater conditions, because these affects, for instance, the floods, and try to reduce the inflow of water into the sewage or basically below the cities, for instance. It's possible to increase the amount of green areas in cities. It's possible to use restoration plans, and there are actually some like storm breakers walls that can be built. But a lot of effort should also go, for instance, on the forecasting and to understanding these weather phenomena. And of course, if we can reduce emissions, we can possibly reduce, let's say, the energy available for the storms. So that as a byproduct should also help this situation. Is the fact that a normal street, concrete or of bricks, cannot really soak the rainwater. So once rainfall arrives on the surface, it starts running on top of the streets, and the only place where it can go down is in the drains. Now, when it rains a lot, the drains fill up immediately, and then you have basically flash floods all the time, filling the streets with water. Now, the reason why this happens is because the water cannot be absorbed by the soil. So one way to actually improve this, if we go to the next slide, would be to have a way for the water to be soaked up by the surface. Now, there are some possibilities for streets, like well-drained gravel. There are some specific asphalts that are more permeable. But the best way, for instance, would be to have more trees and generally more green. Because what happens when there is a tree is that, first of all, some of the water is intercepted by the leaves. So it doesn't actually reach the surface. It's stopped by the tree itself. Then, when water reaches the soil, if there is a tree or if there is soil compared to concrete, actually part of the water can go down into the soil. And because it can be absorbed, it doesn't flood up immediately, and it has space and time to flow away at another time and at another place. So this would be basically why it happens, and at the same time what we can do. A simple thing would be to have more green or specific types of streets that can absorb the water.